Hello everyone, I'm glad to give you an introduction about our first place solution to CVPR 2021 AliProducts Challenge, Large-Scale Product Recognition. There are 4 members in our team: 曾鹏、密刘涛、石志伟、王志猛. We are from 9YY AI Research. Here are our emails. The main content of the introduction includes the following 5 parts: Overview, data processing algorithms, network structure, other trick, experimental result. In this competition, we have used a 2-stage pipeline that had been validated in our previous projects. In the first stage, we train many models based on the original dataset we won. Then we adopt multi-model voting to clean up the noise samples in V1. The training samples with inconsistent results were removed, and the number of training sets was therefore reduced to 1.6 million from a new training set V2. Then the category of missing data was completed. According to the result, to form the category balanced dataset V3. In the second stage, we carefully train the model. The innate learning rate will be as large as possible, with distribution range of 0.05 to 0.004. Then the learning rate will be reduced as the training proceedings. The backbone used in our final results include NFNet F0, NFNet F3, InfiniNet B3, InfiniNet B4, InfiniNet V2F. All these models will be fine-tuning using the class rebalanced dataset V3. The reason for removing other trained models is due to their low accuracy on the test dataset. They cannot improve the accuracy of the ensemble result. Since the perspective of product placement can often change, we use data augmentations include random crop, random rotation, random horizontal flip. We use SGD as our optimizer and manually adjust the learning rate when training model. Like in the finger, since there are many mislabeled images in the training dataset V1, we use many models to vote for noise samples. The used models include ResNet 50, InfiniNet B3, InfiniNet B4, NFNet F0, NFNet F1, NFNet F3, TransFG, etc. These models were first trained with several apples on the training set V1. Small models were trained with less apples, and large models were trained with more apples. All the models were early stopped when the validation loss is reduced to 1 to prevent possible overfitting. The top 1 accuracy in validation can reach 82% to 86%. After orbiting a higher precision model, we adopt multi-model voting to clean up the noise in V1. We used InfiniNet B3, NFNet F0, NFNet F1, and NFNet F3 for model voting. The training samples with inconsistent results were removed, and the number of training sets were therefore reduced to 1.6 million from a new training set V2. Then the categories of missing data were completed according to the result. to form the category balanced dataset V3. We use a simple network structure. That is, we use different training strategies for CNN backbone and classifier according to the different training stages. In the first stage, they are trained together to remove the noise of the dataset. In the second stage, the classifier uses a flexible learning rate adjustment strategy in order to deal with the different performance of different backbones during training to obtain a more powerful image features. In our experiment, the following tricks were also used to improve the accuracy. First, previous studies have proved that a larger learning rate is suitable for the training set with large noise to prevent overfitting. For the dataset V1, in addition to use a large learning rate, we also add label smooth loss to prevent overfitting. Second, TTA strategy were used for tests which use Gauss fusion random crop to predict 10 times per image. Third, for V2 dataset, the training samples with inconsistent results were removed, and the number of training sets were therefore reduced to 1.6 million. The categories of missing data in V2 were completed according to the result of multimodal voting results to form the category balanced dataset. We do this as follows. First of all, for each class, if the number of categories in V1 is less than 30, then all images predicted as this class will be returned, and the other classes will be selected as top 50 according to the confidence. The backbone used in our final result include InfiniNet B3, InfiniNet B4, InfiniNet V2F, NFNet F0, NFNet F3. All these 5 models are trained on V1 first, and the top 1 accuracy on validation datasets are from 81.73% to 87.3%. And then we train InfiniNet V2F, NFNet F0, and NFNet F3 on V1 and V2 in turn and alternately. The best result on validation dataset we get is InfiniNet V2 trained on V1 and V2 alternately. Finally, we fine-tune all these 11 models on rebalanced dataset V3. The best single model result on validation is 94.7%, which is InfiniNet V2F, trained on V1 and V2 alternately, and fine-tuned on V3. And the final example result on test dataset is 94.42%.